Okay, so here we are addressing some of the problems associated with section 18.1, and from that section there were 3 problems that I had assigned in the homework, and I'm just going to take you through those right now. So the first question is, why is BF3 a Lewis acid and not a Lewis base? I'm hoping that all your work in Spartan makes that pretty clear. But just, I put it up here. So there's boron, there's fluorine. Fluorine, of course, is the most electronegative element. And so all the fluorines are drawing away electron density from the boron. And so it's clearly a Lewis acid, because that boron is starved for electron density. And why isn't it a Lewis base? Well, these fluorines, maybe those could act as lone pairs and be a base, but the same problem occurs, which is that fluorine is the most electronegative element, and it doesn't tend to want to donate its electrons. Now, the situation is a little bit different here in problem 18.13. We've got the fluoride ion, so this fluorine is a little bit richer, feeling a little bit wealthier in electrons, and it's all by itself. Look at all those electrons there. So here's the acid-base reaction between the fluoride and the boron. These electrons right here are going to go and try to attach themselves to that boron. What that's going to do is create a boron with that fluorine right there. So these electrons right here are the electrons that go into that bond. Now the steric number on this boron is going to be 1, 2, 3, 4, so we know that that's a tetrahedral arrangement, and that's why I'm going to draw them like that. And of course these fluorine also have electrons around them. Now this whole thing we would usually draw with a minus charge because we still have an extra electron. Problem 18.15, it's a similar thing. I've laid out, and when you do these problems too, you'll want to lay out where the Lewis base is and show the lone pairs on it. So there's water, a couple different lone pairs. There's CO2. If you had done this structure, and that's a pretty good thing to do, is make CO2 in Spartan. And if you do, you'll see that it has this great big blue spot right in the middle. So that's a pretty good target, and makes it a Lewis acid. I'm going to do this sort of thing. Those electrons come in and hit it right where it's blue and starve for electrons. Now, if that was the only thing going on, then it would be a problem, because the carbon itself can only form 4 bonds, and that would make a 5th bond. So at the same time that happens, we say that one of the pairs of electrons bumps up and just resides as an extra lone pair on that oxygen. So the result of that reaction will be something like this: oxygen, oxygen. We still have the extra lone pairs on that oxygen, and now this pair of electrons now forms the bond between the oxygen and the carbon. Let's see, I'm going to draw a single bond to that oxygen there, because the other one is now up on there, okay, which means that this oxygen has a negative charge. This one is the same, double bond. I've now recognized that the steric number on that carbon is 3, and so the geometry around that is trigonal planar. And let's see, there's another one little problem with this, which is that if you worked out the formal charge on that oxygen, you'd see it's shy 1 electron, and so it has a plus charge. Now, what will eventually happen to this molecule is that one of these protons will leave and pop over there, because it's got a positive charge. So what will eventually happen is that those electrons will return to that oxygen. Off goes the proton to attach itself there. So, and to produce carbonic acid, which I think I'll leave you to finish the drawing. Okay.